In the first part of question 2, the question says, for which values of a and b does the following pair of linear equations have an infinite number of solutions? So these are the two linear equations. This is the pair of linear equations, and we want it to have an infinite number of solutions. Now, for an infinite number of solutions, the condition that needs to be satisfied is that a1 by a2, the ratio of the coefficients of x, should be equal to b1 by b2, the ratio of the coefficients of y, and this should be equal to c1 by c2, the ratio of the constant terms. So that is the constraint we will impose on the coefficients of this pair, and from that constraint we will find the values of a and b. So let's do that. So the coefficients of x are 2 in the first equation and a minus b in the second equation. So a1 by a2 is 2 by a minus b. Then b1 by b2, we have b1 is 3 from the first equation and a plus b, that's b2 in the second equation. So we have 3 by a plus b, the ratio of the coefficients of y. And then the constant terms, so both of the constant terms are written on the right side. So one option is that we bring them to the left side. So we make this 7 as minus 7 and we bring this constant term to the left side and put a minus sign in front of it. But because both of them are on the right side, we can take their ratio directly as c1 by c2. So c1 by c2 is 7 by 3a plus b minus 2. Now what we want is all these three ratios to be equal. And from this equality, we have to find the values of a and b. We have to find those values of a and b for which these three ratios are equal. So let's first work with this equality. 2 by a minus b equal to 3 by a plus b. So we have 2 by a minus b equal to 3 by a plus b. So if we cross multiply, so 2 times a plus b or 2a plus 2b, this is equal to a minus b times 3 or 3a minus 3b. And from here we can isolate a, so 2a on the right side, 3a minus 2a, that's a, and minus 3b adds as 3b to 2b, so we get 5b. So a is equal to 5b. So that is the first constraint we get on a and b. Now let's use this pair of equalities to create another relationship in a and b. So we have 3 by a plus b is equal to 7 by 3a plus b minus 2. But from our first equality, we already have a equal to 5b. So let's substitute a equal to 5b in this second equality. So what will we get? We will get 3 by, instead of a we write 5b. So 5b plus b is equal to 7 by 3a. So 3a becomes 15b plus b minus 2. And from here we get 3 by 6b is equal to 7 by 16b minus 2. And now let's simplify this. So this 3 cancels with 6 to give 2. And now let's cross multiply 16b minus 2 on the left side, 16b minus 2 equal to this 2b goes to the right side, multiplies with 7 to give us 14b. So this is what we get, and from here we get 2b equal to 2 or b equal to 1. So we get b equal to 1, and because a is equal to 5b, we get a is equal to 5. So the values we get for a and b are a equal to 5 and b equal to 1. Now let's verify if we will actually get an infinite number of solutions for this pair. So the first equation is 2x plus 3y equal to 7, and the second equation, in the second equation we have a minus b times x. Now a minus b is 4, so 4x. Then we have a plus b times y, so 5 plus 1, a plus b is 5 plus 1, so that's 6, so 6y. And then we have 3a plus b minus 2. 3a is 15, 15 plus b is 16, 16 minus 2 is 14. So 14 is the constant term in the second equation. And now we can verify that the coefficients of x, the coefficients of y, and the constant terms are all in the same ratio, 1 by 2. So for A is equal to 5 and B is equal to 1, the given pair of equations will have infinitely many solutions. In part 2 of question 2 of this exercise, the question says, for which value of k will the following pair of linear equations have no solution? And this is the pair of equations that we have. Now, for a pair of equations to have no solution, the constraint that needs to be satisfied is that a1 by a2, the ratio of the coefficients of x, should be equal to b1 by b2, the ratio of the coefficients of y, but these two ratios should not be equal to c1 by c2, the ratio of the constant terms. And this is because if this constraint is satisfied, then the two equations will represent a pair of parallel lines which never intersect, and hence the pair has no solution. So let's apply this constraint on the given pair and see what value we get for k. So what we need is a1 by a2. So a1 is 3 and a2 is 2k minus 1. So a1 by a2 is 3 by 2k minus 1. And then we have b1 by b2. So the coefficient of y in the first equation is 1. In the second equation is k minus 1. So b1 by b2 is 1 by k minus 1. So these two ratios should be equal. And now the constant term ratio will be, we can take it directly from these terms on the RHS, because both of the constant terms are on the RHS. So we can take the ratios directly. And c1 by c2 then becomes 1 by 2k plus 1. So what we need is this last ratio should not be equal to the first two ratios. Now let's first use this pair of equalities and see what value of k we get. So we have 3 by 2k minus 1 is equal to 1 by k minus 1. Now if we cross multiply 3 into k minus 1, we get 3k minus 3. And we cross multiply this 2k minus 1 with 1, so we get 2k minus 1. And from here, collect the terms in k. So 3k minus 2k, that's k, and this is equal to minus 3 goes on the RHS, becomes plus 3. So 3 minus 1 is 2. So k is equal to 2. So for k is equal to 2, these two ratios are equal. And what is the value of the third ratio for k is equal to 2? Well, if we substitute k is equal to 2 in the third ratio, we get 1 by 2 times 2 or 4, 1 by 4 plus 1 or 1 by 5. So for k is equal to 2, we find that the third ratio does satisfy this non-equality, this inequality. So for k is equal to 2, we get a1 by a2 is equal to b1 by b2, and these two ratios are not equal to c1 by c2. So k is equal to 2 is our answer. For k is equal to 2, the given pair will have no solution. This is the answer. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.